Well, welcome back. So in this video, I'll explain a concept called as Gini impurity, which is used in decision trees. So the spelling is Gini, Gini, impurity. Okay, and it is denoted by I suffix G. Okay, so the formula for Gini impurity is on some random variable y. It is 1 minus summation of 1 to k probability of yi square. Okay, so this is very similar to entropy, and it is used instead of entropy. Okay, it is not used with entropy. So either you can use entropy or you can use Gini impurity. Okay, that is the main thing. Information gain is compulsory. That is a different thing. Okay, so in place of entropy you can use Gini impurity. That's it. So it is an alternative method. And why is it used alternatively? That you will understand right now, because you see in case of entropy, what is the point? We had to calculate log, right? And logarithm calculation is much complex. Okay, it is not computationally efficient. But here we have to just calculate square. Square is very fast. We can calculate square very fast. That is why instead of using entropy, we mostly use Gini impurity. Even in sklearn, wherever we have decision tree implemented in any of the packages, so the default method which is used is Gini impurity. You can change it to entropy, but the default is Gini impurity only because it is very fast. Okay, and it works in a very similar way to entropy. Okay, I'll just show you with an example. See, let's take a case 1. Let's say positive class is 50% and negative class is 50%. Okay, so what will be the value of Ig, that is Gini impurity of y? It will be 1 minus 0.25 plus 0.25, which is 0.5, right? And what is entropy of y? It is 1. You already know it, how to calculate. Now let's take another case, which is case 2. Let's say now probability of y plus is 1 and probability of y minus is 0. Now what will be Ig of y? It will be 1 minus 1 plus 0, right, which is 0. And what is entropy of y? It is also 0. You know that. So it is working in a similar way. Okay, you can see the difference. Gini impurity is actually giving you the value from 0 to 0.5. Okay, 0 to 0.5, and entropy was giving you value from 0 to 1. That's it. So if I draw a graph, so probability of y plus, for example, and this side, so it will be like this. It is somewhat like this. I'm not drawn it very correctly, but you can get an idea. So this is 1, this is 0.5. Okay, so this is 0.5. This is basically 50% probability, and this is 1. So the curve is similar. That is why it will work in the similar way. It will not give you wrong answer. Okay, it gives the perfectly correct answer, but just you have to understand that the range is different. Okay, for entropy the range is from 0 to 1, and for in Gini impurity it is from 0 to 0.5. Okay, and Gini impurity is used mostly because Gini impurity is much faster to compute than entropy. Okay, and now a few points are left, which I will cover in the next video. Okay, about some when to stop building the decision tree. So see you in the next video. Thank you.